Let's talk about standard form. Consider the number 3. It is a whole number, but we can always write it as a decimal number by placing a decimal point after the 3. Behind the decimal point, we can have as many trailing zeros as we please. We can also rewrite the number 3 as a multiple of a power of 10 by moving the decimal point. Let's move the decimal point once to the right. If we do that, we make the number 10 times bigger. 3 becomes 30. So we need to compensate by multiplying it by 10 to the power of minus 1, which is the same as dividing by 10. This is necessary in order to keep the equality true, because 3 is not equal to 30, but 3 is equal to 30 divided by 10. A number such as 10 to the power of minus 1 is called a power. The number 10 is called the base, and minus 1 is called an exponent or an index. Now, let's move the decimal point twice to the left and see what happens to the power of 10. Now we have 0.3, which is 10 times smaller than 3. To keep the equality true, we need to compensate by multiplying it by 10 to the power of 1, which is just 10. Notice that moving the decimal point twice to the left forces us to adjust the power of 10 by increasing its index by 2. Minus 1 plus 2 equals 1. You can say minus 1 or negative 1. Both are perfectly acceptable terms. Now let's define standard form. Standard form, also called scientific notation, is a way scientists write really large numbers or very small numbers using a special number format. Here's that format. A multiplied by 10 to the power of n, where A represents any number from 1 to less than 10, so numbers such as 1, 2, 5.6, or 8.17 are acceptable values of A. And n represents any whole number, positive or negative. The funny-looking E is a mathematical symbol meaning is a member of, and the strange-looking Z is the mathematical symbol of the set of integers. That's basically a bag that contains every whole number, both positive and negative. Let's look at some examples. The distance between the Earth and the Moon is 384,400 kilometers. Let's convert that into standard form. Let's find the value of A. Remember, it has to be a number from 1 to less than 10. The decimal point is not visible, but it's there behind the first 0 from the right. We need to move it 5 times to the left to obtain a number from 1 to less than 10. Here, it's 3.84400. We can ignore the trailing zeros. By moving the decimal point to the left 5 times, we made the number 100 times smaller. So we need to compensate by multiplying it by 10 to the power of 5 to maintain the equality. A bacteria's width is approximately 5/10 millionths of a meter. That's so small you need a microscope to see it. Let's put this ordinary number in standard form. This time, we need to move the decimal point to the right 7 times to obtain a number from 1 to less than 10. That gives us 5. But we have made the number 10 million times larger. So we need to compensate by multiplying it by 10 to the power of minus 7. Negative indices make numbers smaller. Positive indices make numbers larger. Let's have a look at a few numbers and decide whether they are in standard form or not. If they are not, let's put them in standard form. The first number is in standard form. The second number is not in standard form because the a part, 0.72, is less than 1. We need to move the decimal point so that it lies between 1 and 10. Here, we only need to move the decimal point once to the right. Moving the decimal points to the right makes the number larger, so we need to adjust the power of 10 to maintain equality. Now, moving the decimal point once to the right means that we need to decrease the index of the power of 10 by 1 to balance things out. The third number is not in standard form. The a part is bigger than 10. We need to move the decimal point such that 862 turns into a number from 1 to less than 10. We achieve this by moving the decimal point twice to the left. This gives us 8.62. We need to adjust the power of 10 by increasing its index by 2. Minus 5 plus 2 is minus 3. Let's talk about arithmetic operations with numbers in standard form. We have here two numbers written in standard form. Let's add them up. We want our final answer to be in standard form as well. The first thing we want to do is to make their powers of 10 the same. We can choose, for example, to make all the powers of 10 to have an index of minus 3. So we need to modify the first term by moving the decimal point of 2.5 to the left once. Moving the decimal points to the left makes a number smaller, so we compensate by increasing the index of the power of 10 by 1. Minus 4 becomes minus 3. We end up with 0.25 times 10 to the power of minus 3. Put the a parts together and factorize, process the brackets, and get the final answer. We must make sure that the final answer is in standard form. If it is not, we need to make the necessary adjustments. Here, our final answer is already in standard form, so we are done. Let's work out the difference of these two numbers written in standard form. First step is to make the indices of the powers of 10 the same. Let's make all of them 5. Let's move the decimal point of 4.5 to the right once. This will make the number larger. 4.5 is now 45. To compensate, we reduce the index of the power of 10 by 1. 10 to the power of 6 becomes 10 to the power of 5. Bring the a parts together and factorize. Process the brackets. We obtain a number that is not in standard form. Let's make adjustments. Move the decimal point of 35.76 once to the left, making it smaller, and compensate by increasing the index of the power of 10 by 1. We are done. Let's calculate the product of these two numbers in standard form. Remember, the result of a multiplication is called a product. First, we multiply the a parts together. Then, we multiply the powers of 10 together. 4.5 times 1.24 is 5.58. To multiply the powers of 10, we just add their indices. -3 minus 2 equals -5. Remember, we can only add indices like this to multiply powers when the powers have the same base. In this case, the base is 10. The result is already in standard form. We are done. Let's calculate this quotient. Remember, the result of a division is called a quotient. Let's rewrite it by replacing the division symbol by a fraction bar. First step, 4.5 divided by 3. Second, we divide the powers of 10. To do this, we only need to subtract the index at the bottom from the index at the top. 8 minus 6 is 2. So our power of 10 is 10 squared. The final answer is already in standard form. We are done.